This video covers the topic of circular motion. Circular motion is the movement of an object along the circumference of a circle or rotation along a circular path. Say you're swinging a ball above your head at a constant rate that is attached to a string. The ball is accelerating because it is constantly changing direction and is constantly in motion. Therefore, the circular motion of the object has centripetal acceleration. There are two ways or equations to find the centripetal acceleration of an object. Now let's develop the first equation. Because we know that velocity equals change in x over time, we know that x, which is the circumference, is equal to the radius times pi. Because time is also equal to the radius times pi, or the distance over velocity, we can say that acceleration is equal to change in velocity over time. It can be said that acceleration is equal to change in velocity over the radius times pi over velocity. If we simplify this equation, centripetal acceleration is equal to velocity squared over the radius. The units for centripetal acceleration is in g's, otherwise known as gravity. 1 g is equal to 10 meters per second squared. The second way to find centripetal acceleration is when you're given rotations in time. First, you find velocity by using the equation velocity is equal to 2 pi times the number of rotations over time. Once you do this, you can plug the value you find for velocity into the centripetal acceleration formula. Now, let's do an example. A child is swinging on a tire swing with a rope that is 4 meters long at a speed of 8 meters per second. Find the centripetal acceleration of the child on the swing. Because we are given the radius and velocity, we can plug these values into the equation for centripetal acceleration and get 8 squared over 4, which is equal to 64 over 4, which is equal to 16 meters per second, or 1.6 g's. So now let's do an example given the number of rotations in time. A tennis ball on a 4-meter string does 6 rotations around a child's head in 6 seconds. Find the centripetal acceleration of the ball. Because we know that velocity is equal to 2 times pi times the number of rotations over time, we can find velocity plugging in these values and get 2 times pi times 6 over 10, which is equal to 3.8 meters per second for velocity. Now we can plug this value for velocity into the original centripetal acceleration formula, v squared over the radius, and get 3.8 squared over 4, which is equal to 14.44 over 4, and so we know that centripetal acceleration is equal to 3.6 meters per second.